Okay, so it basically tells you that you have a bacteria culture that grows with a constant relative growth rate. Okay, so that means that you know that the population of bacteria is of this form. Now, it tells you that the count was 400 after 2 hours. So you can say that t is measured in hours. You know that then this is 400, and you have this first equation. You have e to is equal up, and wait, you know that that t is 2. Then it tells you that if there's 6 hours, you have that it's 25,600 is equal to a to the 6k, right? E to the 6k. And you have these two equations then. Now you know, first of all, you knew that this equation was the case the moment it said that it has a constant relative growth rate. Okay, you know that anything with a constant relative growth rate is of this form. Okay. P of t is equal to a, the initial amount at any time, e to the k. K is the constant relative growth rate, and then times t. So you know it says that, then you know it's of this form. Now it gives you two more pieces of information. It tells you that there's 400 after 2 hours, and that there's 25,600 after 6 hours. So with these two equations, you can solve for k and a, or a will cancel out. So how do we do this? 400 is equal to a e to the 2k. And then what I'm going to do is I'm going to take this, and I'm going to solve for, I'll divide by a on both sides. You get 400 over a is equal to e to the 2k. And then I'm going to say that e to the 6k is equal to e to the third, or e to the 2k to the third, right? So this will allow me to solve for it, because I just sat here and I just played with these equations, because it's two equations and two unknowns. So we should be able to manage. Now, again, I took this e to the 6k and I wrote it as e to the 2k to the third, because that's e to the 6k. I have an expression for e to the 2k. So in this one, I got 25,600 is equal to a times, but now this here, right, I'm going to write this as this e to the 2k as 400 over a to the third. And that's going to allow me to solve for a, because you see, again, e to the 2k, when I use this equation, right, I can solve for e to the 2k, and that's going to give me that it's 400 over a squared is equal to 25,600. And then I multiply by a squared, and I'm going to get an original amount, because I could divide. I'm going to get a squared is equal to, cancels, 4 over 25, right? And it's nice because then this tells me that a is 2, because it's the square root. I only take the positive. 256 is 16? And this is 1/8. So now I've gotten a, and once I get a, I can solve for k. Okay, so I just sat here, I just played with these two equations. These two equations were key. Seeing how to use these two equations wasn't so easy, but if you follow along with that logic, just go back, just see how it is that this equation is true from this one, right? And then see how it is that you plug this to get an expression for e to the 6k, and then you plug that into here, the second one, and then you can solve for a. Once you have a, now I have, right, whatever, 400 is equal to 1/8 e to the 2k. Then I take ln of both sides, or I multiply by 8. Let's multiply by 8 to start. 8, 16, 24, 32. 3200 is equal to e to the 2k. I take ln of both sides. I'm going to get ln of 3200 is equal to 2k. And then I divide by 2, and I get k. K is equal to ln of 3200 by 2. And then I have the relative growth rate, and I have a. So I have the full function, because a and k are the only things that are missing in the general function. Now that I have that, though, you want to sort of use this fact to just write what you get, and then you can use it, because also you can simplify it a great deal. So I have p of t is equal to a e to the kt, and I solved for a and k. A was 1/8, e to the k. K now is this ln 3200 over 2. So let's remember that 3200 over 2, ln 3200 over 2 times t. And we want to look at this here, because there's a much nicer way of writing this function. It's 1/8, but then this is e to the ln of 3200, right, all to the 1/2 t, right? And then this just becomes 3200. So you get 1/8, 3200, 1/2 t. And that's a much nicer function for p of t. And now that we have p of t, right, we can answer all these questions that they say. They say, what's the relative growth rate? The relative growth rate is ln 3200 over 2. That's k. Okay, that's A. B is, what is the initial size of the culture? 1/8. C, the initial size, right? When t is 0, you get 1/8. Find an expression for the number of bacteria after t hours. Oh, they want it as a percentage, this number, but okay, whatever. C, it says find an expression for the total number of bacteria. That's this, after t hours. Find the number of cells after 4.5 hours. Find the growth rate after 4.5 hours. So the growth rate after 4.5 hours, that's actually a good question. dp dt, right, should be the k value. It shouldn't change. So it's e to the ln 3200 over 2 times t times the derivative of this, which is ln 3200 over 2. That's dp dt. So wait, what is the growth rate? After 4.4 hours. Well, yeah, what is the growth rate? Okay, don't worry so much about finding the growth rate. As long as you get to this and you get that equation, you're good. This is part C. D, let's leave as a question mark. Let's do it at some other point. E, find the, oh no, it's E. Okay, D is just P of 4.5. And then E is the growth rate after 4.5 hours. So the growth rate after 4.5 hours, dp dt, yeah, I guess it's dp dt. You get this, right? E to the, you can differentiate this one, which is a to the t, but you're gonna have to use chain rule, so it's 1/2 ln of 3200 is a division though. I forget how to get, what's the derivative? D dx of a to the x. What is it equal to? Is it ln a to the x, or is it division? simplify that. Y is equal to a to the x ln 1 over y prime is equal to x ln a, and then it's right, the derivative is just ln a, so then y prime is y times ln a, and it's multiplication. Okay, so it's this one. That's good. Okay, and then now that means that this is a to the x, so the derivative is ln a times a to the x, which is 3200 1/2 t, times the derivative of that, which will be 1/16. And then this is the growth rate at any time. And that should be equivalent to what I got before, and then you would plug in 4.5 here is my conjecture for the answer for E. So whatever this is to the 4.5 is your answer for E. But it's okay. That's okay. Just get to C for now, and then we'll go back and we'll look at this and see how it is that they went.